Hi everyone, welcome to my channel Master Engineer. In this video, I'm going to talk about structural analysis, in particular statically determinate structures or beams. To do that, we first need to know a few things about structures. The first thing we need to know is a plane structure. A plane structure is a structure which lies within a single plane, i.e. in two dimensions. So any structure lays within the x and y-axis is called a plane structure. The second thing which is very important to know and understand in structural analysis is the state of equilibrium. So what is equilibrium? In order for a structure to be in equilibrium, the effect of load, which tends to move or rotate the structure, must be balanced by reaction forces developed at the support upon which the structure is erected. In this diagram, we have a beam which is carried by two supports. The one in the left is a pin support. The one in the right is a roller support. Each of them react differently. And we have a point load acting downward. A loaded structure is in equilibrium if it doesn't move, i.e. in a straight line, or rotate, or a combination of both. If this beam does not move vertically in a straight line or horizontally, then the beam is in equilibrium. Conditions for equilibrium. The requirement that a plane structure does not move in any direction may be specified by stating it must not move in any two perpendicular directions. Normally, but not essentially, the two directions are taken to be horizontal and vertical. The structure will not move in any direction provided that there is no resultant force in that direction. For no movement in the horizontal direction, the algebraic sum of all forces acting horizontally must be zero, i.e. the sum of all horizontal forces must be zero. Similarly, for movement vertically, the sum of all forces in vertical direction must be zero. Also, the plane requirement that a structure does not rotate in a plane implies that it cannot rotate about any axis at right angles to that plane. Therefore, there must be no resultant moment or force about any point in the plane. So for no rotation in the plane, the sum of the moment of all forces about any point in the plane must be zero, i.e. sum of all moment must be zero. The sum of all the vertical forces must be zero, which is stated here, and the sum of all horizontal forces must be zero, and the sum of all moment at any point, either B or A in this case, must be zero. The three equations are for statically equilibrium of a plane structure. Therefore, these three equations are very important and they are called the equation of equilibrium. If a structure is provided with just sufficient support, no more than three unknown equations, it may be completely analyzed by use of the above three equations and is externally statically determinate. If you have three unknown forces, then that is externally statically determinate. We can use these three equations to find the three unknowns. But if there are more than three support reactions, then a solution is not possible by the use of above equations alone, and the structure is statically indeterminate. In other words, if you have more than three unknown, then we cannot use these three equations. But if there are more than three support reactions, then a solution is not possible by the use of above equations alone, and the structure is statically indeterminate, i.e. if we have more than three unknown, then we cannot use these three equations to find the unknowns. Beams. A beam is a properly supported structural member capable of carrying loads that are perpendicular to its longitudinal axis, as shown here. An applied load could be concentrated at a specific point, also called point load, or it could be uniformly distributed load, also called UDL. Normally, beams are assumed to bend when they are loaded, although the amount of bending is often very small and may not be visible to the naked eye. For illustration purpose, we draw them in an exaggerated manner as shown. Beams need to be properly supported in order to be able to carry their load. The most common types of support are pin support, roller support, and fixed support. They could be seen in the real life, such as this for pin support, or this for roller support, or even this for fixed support. Each type of support exerts one or more forces on the beam, which are called support reactions. A pin support provides two reaction forces, one in the X direction and one in the Y direction. A roller support has only one reaction force, which is always perpendicular to its surface of contact with the ground. Finally, a fixed support provides three reaction forces, one in the X direction, one in the Y direction, and a bending moment about Z axis, which is perpendicular to the two-dimensional surface represented by the XY plane. In the next video, we'll go through a worked example as shown how to determine the reactions. Thanks for watching, and remember to subscribe to our channel and hit the bell to get all the latest videos.